Today we are going to discuss reaction with metals. So let's read from the book. Most organic chloride, bromide and iodide react with certain metals to give compounds containing carbon-metal bonds. Such compounds are known as organometallic compounds. An important class of organometallic compound discovered by Victor Grignard in 1900 is alkyl magnesium halide (RMgX), referred as Grignard reagent. These reagents are obtained by the reaction of haloalkanes with magnesium metal in dry ether. Now let's examine the reaction. This is bromoethane. When it reacts with magnesium in dry ether, it gives Grignard reagent. In this reaction, magnesium gets inserted between carbon and halogen. So here you will get ethyl magnesium bromide. So here you will get ethyl magnesium bromide. In Grignard reagent, carbon-magnesium bond is covalent but highly polar, with carbon pulling electrons from electropositive magnesium. Magnesium-halogen bond is essentially ionic. Now let's try to understand it. Here it is given R, single bond magnesium, and it is bonded to halogen. The bond between magnesium and halogen, this is purely ionic bond. This bond is purely ionic bond. As halogens are electronegative and magnesium is electropositive. This is electropositive element. It is a strongly electropositive element as it belongs to second group of periodic table, and halogen belongs to 17th group of periodic table. That's why they are strongly electronegative. So the bond between electropositive magnesium and electronegative halogen is purely ionic. But the bond between carbon and magnesium, this bond is covalent bond. This is covalent bond. This bond is covalent, but due to highly electropositive magnesium, this bond is polar. As the bond is highly polar, magnesium will become delta positive as it is electropositive element, and carbon will become delta negative. Now let's read from the book. Grignard reagents are highly reactive. They react with any source of proton to give hydrocarbons. Even water, alcohol, amines are sufficiently acidic to convert them to corresponding hydrocarbons. When you see in this example, this is RMgX, Grignard reagent, when it reacts with water molecule. It results in the formation of RH, which is the hydrocarbon. Now let's try to understand this reaction. This is RMgX, and we just have learned that magnesium is electropositive element, so it will develop delta positive charge and carbon will develop delta negative charge when it reacts with water molecule. So this is H2O. You can split water in the form of H plus and OH negative ion. This positive hydrogen will go to the negative carbon and this negative hydroxy group will go to the positive magnesium. So here you will get R will get attached to hydrogen and magnesium will make bond with the hydroxide, and it is already bonded to halogen. So that's how you will get hydrocarbon. That's why it is written here, Grignard reagents are highly reactive. They react with any source of proton to give hydrocarbon. Therefore, it is necessary to avoid any traces of moisture from a Grignard reagent. That is why reaction is carried out in dry ether. On the other hand, this could be considered as one of the methods for converting halides to hydrocarbon. Now come to the next reaction, Wurtz reaction. Alkyl halide reacts with sodium in dry ether to give hydrocarbons. containing double the number of carbon atom present in the halide. This reaction is known as Wurtz reaction. Now let's examine the reaction. In this reaction, there are two molecules of alkyl halide. When they react with 2 moles of sodium, it gives you hydrocarbon and 2 moles of sodium halide. Now let's try to understand this reaction by taking one example. So if I take the example of chloromethane. See, it is bonded to Cl, and here there are 2 molecules of chloromethane. When they react with 2 moles of sodium, sodium removes chlorine from the molecule, and here you will get CH3, they make bond with each other, and here you will get 2 moles of NaCl. So in this hydrocarbon, here you will get ethane having 2 carbon atoms, while in the alkyl halide it was chloromethane. Which has just 1 carbon atom. So that's why it is written here that you will get the hydrocarbon having double the number of carbon atoms present in the halide. So here you will get the hydrocarbon having double the number of carbon atom as in case of alkyl halide. Now let's try to solve a few questions based on it. Here a few questions based on Wurtz reaction and Grignard reagent are given. Question number 6.9. Identify A, B, C, D, E, R and R dash in the following. In the first question, this is bromocyclohexane. When it reacts with magnesium in presence of dry ether, it gives you A. When it further reacts with water, it gives B. Now let's try to solve this question. So let's draw the structure of cyclohexane. This is cyclohexane, and here it is bonded to Br. When it reacts with magnesium, magnesium will get inserted between carbon and bromine. So here you will get cyclohexyl magnesium bromide. So here magnesium will get inserted between the carbon and bromine. So this is nothing but the Grignard reagent. When it reacts with water molecule, so water can be written as H plus and OH minus. And we know magnesium is electropositive, so it will develop delta positive charge and the carbon will become delta negative. So H will go to the carbon and OH will get attached to magnesium. So here you will get, this is cyclohexane, and here this carbon will get attached to hydrogen, and magnesium, which is already bonded to Br, will make bond with the OH negative ion. So here this is A and this is B. B is the cyclohexane. Now let's read the second question. Here RBr, when react with magnesium in presence of dry ether, it gives C. When it further react with D2O, D2O is a heavy water, it gives this compound. Here you have to identify this C. Now let's write down the reaction. This is RBr. When it reacted with magnesium in presence of dry ether, it gives you C. When this C react with D2O, it gives compound CH3, CH, CH3 and D. Now we have to find out C and R. So let's try to solve this question backward. D2O is nothing but the heavy water. So we can write it as D positive and OD negative. And we know D positive get attached to this carbon. Means this carbon is the carbon to which magnesium was bonded. Now let's try to draw the structure of C. Now let's draw the structure of C. Here this is the center carbon CH. It is already bonded to two other methyl groups. This is CH3 and CH3. And this carbon is bonded to magnesium and magnesium is bonded to Br. Now we know the structure of C. Now we have to identify R. When RBr reacted with magnesium, we know magnesium gets inserted between carbon and bromine. When you remove magnesium from here, you will get the structure of alkyl bromide. Now let's try to draw the structure of this by removing magnesium from here. So here we will get CH, this is CH3, CH3 and Br. So when you remove magnesium from here, you will get the reactant, in which R group is isopropyl group. So R is isopropyl and C is isopropyl magnesium bromide. This is isopropyl magnesium bromide. Now come to the third question. Here R1X is given. When it reacts with magnesium, it gives D, and when it further reacted with water, it gives E. When this Rx reacted with Na in presence of ether, it gives this compound. Now let's try to solve this question. First of all, draw the structure of given molecule. Here it is given CH3, 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 CH3 and CH3. When it reacted, when R-X reacted with sodium in presence of ether. So this reaction is Wurtz reaction. Now let's try to solve this question backward. First of all, we need to identify this R. And we know in the Wurtz reaction, two molecules of alkyl halide join together. So you just have to split the given molecule into equal halves. So here we can split this molecule into equal halves. Now copy half of the molecule, which is your R dash. So here R dash will be CH3, C, CH3, CH3. This is tertiary butyl and which is bonded to X. In Wurtz reaction, when these two tertiary butyl halide reacted with sodium in presence of dry ether, these tertiary butyl groups join together and halogen is removed in the form of sodium halide. So that's how you will get this molecule. So now we have identified R-X. So this is the tertiary butyl halide when it reacts with magnesium. So here you have to write the reaction of tertiary butyl halide with magnesium. And now you know, you just have to insert magnesium between carbon and halogen. So here you will get the structure of tertiary butyl magnesium halide. This is tertiary butyl group. Magnesium will get inserted between carbon and halogen. So this is the structure D. When this tertiary butyl, when it reacts with water, and you know water can be written as H plus and OH negative ion. And here this carbon will develop delta negative charge and magnesium is delta positive. So OH negative will get attached to magnesium and H positive will get attached to partly negative carbon. So here you will get CH3C. This is tertiary butyl group and it will get attached to H. And here you will get MgOH X. So this is the structure of E. E is the isopropane. or 2-methyl propane. And D is tertiary butyl magnesium halide. R is tertiary butyl halide. In the next video, we will discuss reactions of aryl halides.